Good evening, this is the Science Discovery channel. Today there's an exciting explanation of how zinc can be used as an antimicrobial agent for Streptococcus A. Zinc is considered as one of the fighting components of white blood cells, in this case neutrophils, but the pathogens itself also requires a limited amount of zinc to survive. Although the white blood cells use zinc as an antibacterial agent, the uptake and release of zinc is a regular process of GAS to keep the cells alive, also known as the zinc efflux system. A gene in a GAS called CZCD encodes for a diffusion facilitator, much like a channel which allows specific ions to pass through and resist certain heavy metal ions to come in, such as cobalt, cadmium, or zinc. We will pass this on to Dr. Cheryl Lynn Ong, a research fellow from the University of Queensland. Thank you, Julie. We investigated the effects of how these pathogens would react under zinc stress and the degree of acting viral to measure the bacterial resistance. This was carried out by creating two mutant genes closely resembling those found in GAS. The two GAS mutant genes were constructed to be without the CZCD gene and the GCZA gene. Let's call them deletion mutants for short. So, therefore, the deletion mutants would exist without a zinc efflux pump. The deletion mutants' behavior will compare to random wild-type bacteria and the two complementing genes of the mutant genes, which are similar in genetic components. As expected in the presence of GAS, GCZA would increase CZCD gene expression in response to increased levels of zinc. Differently, when in the presence of zinc, the two deletion mutant species were sensitive and also skeptical to the attack of neutrophils and reduced viral-like activity. All of the components were tested in the presence of white blood cells and revealed that the deletion mutants had a significantly reduced capacity to survive against these white blood cells' fighting mechanism compared with the wild type and the complemented mutant strains. The neutrophils would accumulate the zinc when it is infected, whereas zinc levels lower when there is no detected pathogens. With consistent observations, the wild-type bacteria resist the white blood cells' mechanisms, which better than the mutants without the zinc efflux in presence of zinc, which means that the inactivation of the efflux transporters has been shown to decrease the viral capacity of the GAS and other pathogens such as E. coli and Salmonella. Summarizing, both zinc acquisition and zinc efflux is required for GAS pathogenesis, and neutrophils use zinc poisoning for killing. Thank you very much, Professor Cheryl Lynn Ong. Thank you for joining us tonight on the Science Discovery channel. My name is Julie Truong, and have a good night.